kept this cluster inside of this container. So at the time, we can say that we run containers on cluster inside container. Yeah, this cluster was then moved to the new building. In total, it has 3,300 cores, 15 terabytes of RAM, and something about 94 teraflops. It's not much today, but in 2013, it was enough for our purposes. So the second cluster is named Salomon. The name is based the same way as the Anselm. Is the name of the same coal mine. The name changed of the coal mine in time. So yeah, we upgraded to CentOS 7.6.2. This cluster, the number of software is a little bit higher there, but not significantly. It has 1,000 nodes based on Intel Haswell. Half of the nodes are without acceleration, with 2 Haswell CPUs per one node. In total, it's 24 cores. And second half is with 2 Intel Xeon Phi accelerators per one node. The curiosity about this is that at the time, it was the biggest installation of Intel Xeon Phi in Europe. Yeah, and we have one fat node which have 120 cores and more than 3 terabytes of RAM. Yeah, you can read the totals here. I think it's not interesting. Maybe more interesting is that this supercomputer was 40 in the world and 14 in the Europe at the 2015. Yeah, this is our next cluster, next small cluster. It's codename URX, but we don't know the name right now. It will be the small cluster only with 200 nodes based on the Intel Cascade Lake, and we should have this one in somewhere in April 2019, so in 3 months maybe. Yeah, I'm a part of Supercomputer Services department. We have 10 system administrators, and we are doing almost everything that is needed. So from the applications, that's mostly my and my colleague work. Through the network, we develop our own informating system. We are doing user support, and recently we started to do hardware maintenance of our cluster, because this cluster is pretty old right now, so we don't have anyone to do it for us. So we are doing the hardware maintenance too. And we have two infra admins that's just doing the cooling, heating, because we are heating our building by the supercomputer. We are using the heat from supercomputer to heat our building. And things like powering and etc. So let's move to the EasyBuild stuff. Yes, as I said, we are using the CentOS 7.6. For modules, we are using Lmode 777. We don't have a reason for it, I think. We just like the numbers. And it's working, so why change it? The EasyBuild version is every time the latest. And we digged a little bit, and we found that we started to use EasyBuild in 30 January 2015. So today it's 4 years. We should celebrate. Yeah. Something like default toolchain is not like strictly default. Is GCC 630. The reason is that this is the most used toolchain on our clusters, and no, it's most or just plenty of modules are compatible with this GCC version, and then we can easily combine it together, and we don't need like one software with 10 or 20 different toolchains. Or we like dummy. I know that you hate it, but we like it. And in case of CentOS 7.6, we don't have problems with dummy toolchains because most scientific application is compatible with CentOS 7.6, and we don't have reason to use a new toolchain or new GCC. Yes, in case for some high-level scientific software, or how to say it, we use the newer GCC because of the performance of that software. So the performance, the optimization can be better on the new GCC, but for some, I don't know, graphical interfaces and graphical libraries, we just use dummy because it's enough, and we can share one module, dummy module through many applications. Yeah, we have our own Easyconfigs and EasyBlocks. I will tell something about it later. Yeah, the software is on shared storage, but the storage is shared only per cluster. So when we have two clusters, we have separate storage for each cluster. The reason is mostly that there's different CPUs. We have Sandy Bridge with AVX and Haswell with AVX2. So we need to compile it again. So we don't have share storage through all clusters, only per cluster. Yeah, we are using the flat naming scheme because we have bioinformatics, and everything from the Lmode is automatically grabbed, and the module metrics on our website is automatically generated. So when we add a new software, it's immediately on our web. Yeah, and the last thing that is for us, the most important, is that EasyBuild is a good servant but a bad master. So it's a pretty good tool, and it can do much things. But sometimes we just need the dummy toolchain, or we need to just edit something inside of the EasyBuild, so it can work like we need it. So we need to bend it a little bit sometimes. Yeah, about the upgrading from the CentOS, there's one thing. We upgraded from CentOS 6.9 to 7.6, and it was a software disaster because almost everything stopped to work, and the main reason was not that we are using the dummy toolchain. Not that was the smallest problem. The biggest problem was with C library or glibc library that changed, and plenty of software just search for the exact version of the glibc. And it's inside of the code of the application, inside of the binary. So we have to rebuild everything on our clusters. So we decide to mark every software before the upgrade with a tag C6, and then we rebuild what we needed. So after rebuild, the module file was generated again, and this tag just disappeared. You can see it here. So just some old versions of OpenMPI we don't rebuild because nobody wants this software. So for now it's still marked as old software, CentOS 6 software, and maybe if nobody just tell us that need it, we will delete it. So it's something, it's some way how to just get rid of software we don't want. Yeah, but this was pretty hard. Into people just reinstall, I don't know, maybe 50% of software on the cluster in something like 2 weeks. Without EasyBuild, we can't do this.
One thing you could do here is hide the old broken modules. You can just tell Elmod not to show them in the module.
Yeah, we can. But our users know how to show the hidden modules. That's the one thing we realized. Yeah. And the second thing is that we don't need to hide it. Our users know, and we have it everywhere, that we moved from CentOS 6.9 to 7.6. And what we need is to just know if somebody needs that software. If don't, after, I don't know, half a year, maybe a year, we just will delete that software and we will not ask our users.
And that's when they will tell you the
Yeah. I think you're right. Every time we something delete because we just old software that we think it's too old, we mark as obsolete, and we show just O in the listing that is obsolete. But users are continuing to using it, don't care about the obsolete notice there. And then when we delete it, we have a ticket. Just please install this software, it stopped the work. So yeah, I think this will be the same story, but I have no idea how to manage if someone needs this old software or not. Yeah, so back to Easyconfigs, we have our own public repository where we have 2,900 Easyconfigs. That's different from the upstream for 700 different software. And we have 187 software that is not in the upstream. I will get to this later because it's because of some changes we made. How we distribute the Easyconfigs? Mostly we are trying to keep things as simple as we can. So we just have Git repository, one branch for every supercomputer. Then we just install the software on the one supercomputer, and we have scripts that will merge these changes to the master and then will propagate it to the other branch. The reason for this is that one software can be installed by different way on different clusters. There are different architecture, and there can be a different operating system. So in this case, we can have different version of the same named EasyBuild, Easyconfig file. I don't know if it's a good idea, but it's working for more than 3 years right now, so we get used to it. And it's simple. in comparison to continuous integration, Jenkins, and other things. For us, maybe we will have 4 clusters, 5 clusters, and then will be unusable. But right now, it's okay for us. Yeah, EasyBlocks. We have our own EasyBlocks, but mostly it's only a little bit changes. We did only a little bit changes to the EasyBlock in some emergency cases that something stopped to work and we need just to install some application or modify the installing process a little bit. Nothing huge like own EasyBlocks made from scratch. Yeah, we are not able to do such a huge things. There is some sample of one modified EasyBlock. I think it's absolutely unreadable right now. But what we did, we needed to install MATLAB, for example, but we have still two keys and separate solvers in each key, and we have to install the solvers from both keys. And okay, this is old. Maybe just now you can do it, but this is old.
Yeah, this exact issue was fixed in the latest release.
Yeah,
so you don't need a custom.
This is, I think, a year or something like that old.
Yeah.
Maybe more. So we just use the part of code, Control-C, Control-V. We use some unused variable. Maybe I can find it. But a variable in EasyConfig, because we were so dummy or so lazy. We reuse key and X default class because that was not used. Yeah, we are lazy. Yeah, so maybe that's about the EasyBlocks. You can see this mess on our Git repository, but I don't recommend to use it. Yeah, and what we did is we made our toolchain. We named it Py because it's for Python packages, and we had a problem that every upgrade of Python, we have to reinstall all packages to this Python, and because sometimes just users request, I need this package and I need this package, so we install other packages inside, and this changes was in runtime, not in the EasyConfig. So we lost track about the packages inside and everything. So we try to make our toolchain Py, which is based on GCC core 630, and include Python 2.7 or 2.6, depending on the version. We have base version of the Python only with, I think, 2 or 3 basic packages inside. Some setup tools or something like that. And then every module is installed as a separate, every package is installed as a separate module. The main thing about this is that we can change the Python module, and we don't need to reinstall all Python packages. We already did it sometimes or a few times, and it looks like it's working or in working condition right now, and nobody just have reported an issue in a year.
So is the issue here that every time somebody asks for a new Python package that you have to redo the whole Python installation? Is that the problem
Not exactly. Mostly just somebody load the Python modules and do a pip install procedure.
Right, okay.
Yeah, and we lost track about what's there, and we had, I know, 20 versions of Python, different packages inside every Python. So when we upgraded Python, then we have ticket to add this package to this Python too. So yeah, so this was something like experiment from us, because I was just curious if this can work, because the Python path is long. Yeah, if we load 20, 30 packages, it's pretty long. But we don't have any issue with this, and we can have more version of the same package, Python package, so we can trace the dependency and other things. Again, I don't know if this is clever thing, but it's working. So maybe it's only thing we can think about this, if it's a good thing or not.
I was gonna say something, I forgot. Damn. It'll come back to me.
So I don't think I understand what you're doing with the Python. So you just have like directories with all the Python modules in that, and when a user does Python load 2715, you're creating a whole bunch of Python paths to find all these different modules.
Not exactly. We are using the Python modules the same way like the L-mode modules. So the Python package is installed the same way like any other scientific software. So we download the source code, compile it using the EasyBuild.
So they end up being their own so like Qt4 for Python. It's one Python.
Yeah. It's one package, one module per one package.
Okay, I'm thinking of a design that's the opposite, where you would just have like a big directory of all the Python modules.
Yeah. But in that case, we can't have more version of one package.
Right.
We have only one version.
Yeah.
In this case, we can combine what we just can imagine.
But one thing you have to be aware of here, that the bigger you make Python path, the slower the startup becomes.
Yeah.
Because if somebody does import PyYAML, and PyYAML is at the very end of the Python path, it will run through everything else, hitting the file system. So it has an effect on startup time.
Yeah, I thought that this will be definitely a problem, but as I thought, we have no issue reported.
Nobody's
right now.
Complaining. Yeah.
And the file system that we use is just base network file system storage and NFS storage, and the cache inside of the system works pretty well. So after the first iteration of searching inside of the Python path, the second iteration, I think that the second iteration is much quicker and so on. So our nodes has 64 gigs of RAM at minimum, and on Salomon we have 128 gigs of RAM. So there's plenty of space for cache, or for the file system cache inside. Yeah. So, and because we also missed some functions in EasyBuild, we made a wrapper for EasyBuild, and we just add that functions directly to the EasyBuild, so it's easier for us to use it. For example, after setting up new software, we mostly need to rebuild L-mode cache, because L-mode is cached to so it's quicker to search through the software. And this rebuild is, I don't know, once per 10 minutes maybe, or 15 minutes. So we don't need to wait, we can rebuild the cache instantly. Then we a little bit modified the upgrade of the EasyBuild, install latest EB release, because we have our modification links, module files are different a little bit. Yes, we have this wrapper, so we have to deploy these things. So we just wrap this installation process, and we then continue with our post-install steps. Yeah. Next thing is the containerized parameter, because this not load the Singularity module, because we don't have Singularity inside of the system. We have modules for Singularity with different versions. So we add this, yes, and when we detect a success build, then we can rebuild the L mode cache automatically. So it's easier.
How is this implemented? Is this a shell wrapper around
I
the
think
EB?
it is a shell wrapper, yes.
Yeah. Okay.
Yes.
Because since when did we implement hooks? 3.6, EasyBuild 3.6, something like that. You can actually do this in Python and have it like at least cleaner.
Yeah. There's maybe two reasons for this. The one is that this is maybe 2 or 3 years old. And the second is that we are not so good in Python. We can write scripts in Bash, as we are mostly system administrator, but not the programmers. So we don't know Python so well to. Maybe we can do these hooks, but yes, this is pretty old and it's working. Just works. That's everything. Yeah, and then I was curious what the users do with EasyBuild, because EasyBuild on our clusters is accessible to users and is pre-configured that every user can build software with EasyBuild, and this software will be stored in the home directory on the cluster. And we was just curious if somebody use it and how use it. So we again use our wrapper to spy our users, and we are sending this information to Mattermost, which is just a messaging application. The good thing about this is that I can spy my own EasyBuild process, EasyBuild compilations, and then I can use notify or notification on my mobile phone, so I know that my build is complete or it failed, and I know that I can celebrate or not. Yeah. So that's just another thing. And what we found, yes, our users are using EasyBuild a little bit, but not every time it's a success. And when it is success, then we can steal the Easyconfig and use it. Yeah, we are just small team, and we don't have time for everything, so we have to help somebody from outside. So this is perfect way. Yeah. Then we have some other base scripts that helps us to use EasyBuild. The first is connected with our Easyconfigs mostly, how we distribute the Easyconfigs through the cluster. So this script will do everything for us, and we have everything inside Git. So we have track of module files, Easyconfigs, settings of the EasyBuild, and everything. So if something just screw up, we can get the Git repository and use order commit. EBSSH just connect to all clusters and build some software at once. So this is maybe there should be a picture. So yeah, we know that EasyBuild can do a graph of the dependency for us, so we use that, and it is just a small wrapper to do the graph on the cluster, then copy the graph file to our computer and open it. So it's not so interesting. The interesting thing is we can do the same thing with our module files. That's another small base script that can do something like map of our module files and can generate a graph of dependencies from the module files, so from the state that is currently on the cluster, because Easyconfigs can change in time, and the old software can be installed in just other way. Yes, I know that I can grab just the Easyconfig from the install folder and do it by EasyBuild, but this is way simpler for us.
That's kind of interesting for this remove installation thing, right? It's a reverse lookup mechanism, right? For a piece of software in the system for the modules.
I will
right?
get to this too. Yeah, but the script it's not so clever, so it's just some grabs and other things. So it works, but only in case that the software was installed by EasyBuild. So the syntax is exact the same on every module, and I can grab the dependencies from there.
That's the only software you have.
Yeah, yeah. We have on our cluster we have maybe 2 or 3 softwares installed by hand. Everything else is installed with EasyBuild, and even it's installed by hand, the module file is generated by EasyBuild because we are too lazy. So still there's still I can parse these module files. No. We are not sure if we can just publicly share it. For example, this module can do a big mess on your cluster, or this script. So I don't know if it's clever to distribute script where is something like rm command. Yeah, that is maybe it's safe, but yeah, maybe we can. We have everything already in Git. It's just not public, so maybe we can get it public. So yeah, and the last thing I would like to say is that we have script to remove modules and the dependencies of the modules. So there's just I don't know what it is, LLVM, yeah. In case I would like to remove the LLVM module, I can use this script. It will check the dependency. It will check every software in the dependency if it's independent or some other software is dependent on the software. So I know that this software I can remove because some other application is dependent on that. So in this case, I know only that LLVM is okay, but zlib and cardis I can remove. So the script will find the root of that application, the module files, and then just delete it. That's all. It's a simple script. What's interesting is the finding of the dependencies, I think.
This only removes the modules. It leaves the installation directories there, or
no. It will remove the root directory of the application too. Okay. Yeah, we can use maybe the better idea is to move the application somewhere else. Maybe.
Safe, yeah.
But sometimes we just have to try some software with a new toolchain. So we build whole toolchain, every dependency, maybe 20 packages. And then we realize that we don't need it because it's not working like we need. So we have to delete every software. So 20 packages to delete, so 30 files to delete by hand.
Yeah.
The script can do it at once, almost.
So suppose the zlib module is not used by anything else, it would also be removed here.
Yeah.
This is exactly what a removal feature in EasyBuild should be doing, right?
Yeah. We are hoping that this will be in EasyBuild.
Yeah. Showing you what it considered, showing you what is okay to remove, and then asking for confirmation after giving you a list.
Yeah. I have the force parameter there too, so you can use force and then
and
no questions.
So the problem here is, well, now it's not green, but suppose zlib is green.
It's green on my screen.
No, I mean LVM is green, but
LVM, yeah.
So assume zlib is green as well. it can only do that based on the information it sees, right? Like the current module path.
If the R-link, if the library is linked in other way than the module way, then I will remove it.
Maybe users have built stuff on top of your modules, and then you're gonna break their stuff.
Yeah, so that's the reason we don't publicly share this script. You can do a mess with this script on the cluster.
But yeah, if you do it manually, it's the same issue.
Mostly it's in case just we are trying a new software or new toolchain, and we build plenty of packages, and then we need to remove them. So in that case, it's safe to remove because it's a new package. Nobody knows maybe of this package. But yeah, if it's old package, then you can do pretty.
One question is, so is this, will this only work in a flat naming scheme, or would it work in hierarchical as well? You have flat, right? You use flat scheme.
We are using flat, and I'm not sure right now. Maybe or if not, it's simple to use it with hierarchical. It's undefined, and I'm grabbing or taking these paths directly from the modules. So if it will be in another folder, I can still grab the path and use them.
Yeah.
So I don't know if it will work because I tested only on our clusters, but the modification should be simple to work it somewhere else. So thank you for your attention. That's all from me right now, so you can ask.
Any questions?
So thank you.